we have another hypotenuse number. 15 radical 6 is now equal to this x radical 2. We're going to have to isolate the x term from it, so we're going to divide by radical 2 on both sides. That's gone now. Now we've got 15 radical 6 divided by a radical 2, and that equals x. Now the rules for division of radicals say that radical 2 will divide into a radical 6 3 times. So this cancels out, and that becomes a radical 3. So 15 radical 3 is equal to x. We now can finish our chart. This is 15 radical 3, and this one is 15 radical 3. This x, and x radical 2, this is what is really, really important that you understand. If you could reproduce this part of it, you'll probably have to commit it to memory. That will give you the basis for all of the math, because it's confusing, especially when they reorient the triangles and such. So having a chart, having something that you repeat the same way you do the problem is going to give you more accuracy with the actual answer. You might see an isosceles triangle as a circle with 2 radians coming out. Now you know that the radians are the same length, so these would both be x. And if we connected these points, we would have this 45, 45, 90 triangle. All right, so that's another way that you might see it on a test. Let's give ourselves another number here. Let's make this 12. The hypotenuse is 12, so we've done this. Let's do 12. All right, 12 is the same as x radical 2 is equal to 12. So if we're going to solve this for x, we're going to divide by the radical 2. X is equal to 12 radical 2. We cannot have a radical in the denominator. Those are the rules for division of radicals. So we're going to take it away this way. This becomes a 2. Radical 2 times radical 2 is actually a radical 4, and then that's a perfect square. We can take one of the 2's out to represent the pair, and that's what happens. The radical sign goes away, and we're left with the 2. Eventually, if you just understand that, you can see when you have 2 radicals of the same, it just automatically becomes outside the radical sign as a whole number. So that's a shortcut that you'll have. Here on the top, we've got a whole number and a radical, and it just gets reduced like that. But we have 2 whole numbers now, top and bottom, so this now can go another step. X is equal to 6 radical 2. That's our x term, 6 radical 2, 6 radical 2. Let's go back to our circle, and this time our hypotenuse is going to be 60. Same thing, I have to have 60 is equal to x radical 2. So 60 equals x radical 2. I'm going to be solving this equation. X is equal to 60 radical 2. We can't have a radical in the denominator, so we're going to get rid of it this way. X is equal to radical 2 times radical 2 is 2. And the top, the numerator, 60 radical 2. Again, we have whole numbers here. 2 will divide into itself once, into 30 times. So now we have 30 radical 2 is equal to x. And we can fill in our chart. 30 radical 2, and this x is also 30 radical 2, which gives us our sides as 30 radical 2. And our triangle is complete. This creates a 45 and 45 because these are all 90 degree corners here. And when you bisect it with the diagonal, you've initially cut these into 2 45 degrees. So we actually have 2 right triangles in this square. And let's say that they've told us that the diagonal, or the hypotenuse in this case, would be 14 radical 5. So we know that number. Back to our chart. 14 radical 5. Okay, in this case, we're saying that 14 radical 5 is equal to x radical 2. And now we need to do the algebra solving for. That cancels. And coming over here. All right, so now we have 14 radical 5 over radical 2 is equal to x. This radical 2 does not divide into the radical 5 as easily as, let's say, this one does. So we're going to have to get rid of this in a different way. We're going to have to multiply by a radical 2, both top and bottom. Now this becomes 2. And the top is 14 radical 10. Now we have the ability to cancel here on the whole numbers. So this is 1 and 7. So our x is equal to 7 radical 10 is equal to x. 7 radical 10, 7 radical 10. You've got a lot of things you're juggling right now. The chart actually helps you keep the 45, 90 degree ratio under control. So you're going to take from your information and set it up into these columns and work it however you need to work them. Your nirvana choice would be to have one of these x's first. That would be the best. Because if you knew the x term, let's say it's 3, that would be a copy job here, and the 3 would fit right into the x term there. So that would be very easy peasy. So when we don't have this situation where we can just kind of fill in the blanks, you're going to just follow the rules for algebra as you transfer yourself from one column to another. Then you can mark your picture if you have to draw it, or if it's provided for you, and then follow the additional directions, whether you're taking the interim step to actually find the numbers, and then place them in the picture in order to find area and perimeter. Most usually that's what they ask for.